So first, what do you mean by law of constant? There are two laws. One is this law of conservation of mass. But before that, like, what does the law of conservation of mass mean? It means that if I react sodium sulfate, Na2SO4 plus BaCl2, it will give me BaSO4 plus NaCl. And this will be balanced by this. So if you measure the mass of this and the mass of this before the reaction, this means here we have sodium sulfate, here we have barium chloride. We react them. The important thing to notice is that this is open. It is open here. Now, if this is open, the only way mass can be conserved, there is if there is no gas. Otherwise, the gas will escape and the gas has mass. So if there are some reaction like CaCO3 plus H2SO4 to give you CaSO4 plus CO2 plus H2O, then what will happen? You can't do this because this gas will escape and the mass of the product will not be equal to mass of reactant. So, but here, because you see, this is a precipitate, and this is a aqueous solution, no gas. So the mass is conserved. You can do it in open. Otherwise, you should have put a block here, cork here, so that the CO2 doesn't escape. If you are doing a gas reaction, but there's no gas reaction. So he's saying that he's saying here that since both they prevents by so he's saying the reaction was carried out in open sesame, no gas is formed. So one thing is there, and also notice that what is happening. This is precipitate. So this is white. See, this is white precipitate. BaSO4 is a white precipitate. Why do we do this? Because we know a reaction has happened. Otherwise, how do we know a reaction has happened? We use barium sulfate. This specific reaction because we can see the white precipitate and we also know a reaction has happened, and then we see has the mass changed. You see the mass he's saying is 0.218 and here it is 2. Slight, but this is a difference of 0.001 gram, so which is very small, so we can ignore it because of the instrument problem. And the other thing is there could be a fan running on top or something which has caused this problem, but it is a very small difference. So basically the mass is conserved. Whatever was the mass here, this is conserved. But how do we measure mass? You see, if he is taking grams, and then it can't be like molecules, it has to be moles. So the other law, this law of constant proportion, is talking about the formula. That means he's talking about like what's the mass in calcium carbonate. So he says, okay, we have got let's say he takes water here. He's taking water here. Uh, he's taking water here. Yeah. So he's saying that if 46 reacts completely, how much chlorine is needed to form this? He gives you the mass ratio. Now, why this mass ratio? You see, Na has a mass of, if you see the here, Na is 23. Now, what is 23? It is relative atomic mass. What do you mean by relative atomic mass? It means with respect to 1/12 the carbon. You see, carbon is taken 12 units. So, 23 means 23 into 1/12 of carbon. That means 23 units. So, one sodium atom is 23 units. Now, Cl is 35. So 23 will always react with 35.5. Why? Because Na has got 281, 11 atomic electrons, one electron in the other outer shell. And Cl is 287, 17. So this wants to give 1. So if this wants to take 1, so one atom will give 1, take, and one atom will take. So Na will only react with 1 Cl. It won't react it with 2 Cl, because so that means 1 and 1 will react, and that means 23 will react with 35.5. This is the fixed ratio. So this is the ratio which anywhere you take NaCl, anywhere you take it will be 23 to 35. So if you need 46, if you react 46, you have to, if 20, this ratio, it should be double. So if I'm multiplying this, so we need 46 will require 71. That's the thing. The electrons, it is dependent on how they combine. Depends on electrons. So basically this constant proportion, like water is H2O. Now he is saying that, but one thing you should remember, if he's talking of grams, it is about moles. It can't be AMU. So again, we H2O is H2O, one molecule breaks down into one hydrogen molecule and half oxygen molecule. A half oxygen doesn't exist. So what we do is we assume two H2O break down into two hydrogen molecules and one oxygen molecule. So two molecules of water will break down into two molecules, I'm talking of molecules of hydrogen and one molecule of oxygen. Now, whenever we talk of molecules, we should know that one atom of hydrogen is one AMU. One molecule which is H2 is 2 AMU. But this is just AMU, but we are measuring in gram. So gram is only if it's moles. So if I react this with 6.022 into 10 to the power 23 both sides, I'm not changing anything. I'm not changing anything. 6.023 and 6.0. So now it will convert into moles. Now it will convert into moles and the mass will convert into grams. So this will now, this is 2 is, which was we were considering it as molecules. We can directly write 2 moles of H2O molecule gives 2 moles of H2 molecules and 1 mole of oxygen molecule. Now when we say 2 moles, one atom, one molecule will be 18 AMU, but 1 mole will be of molecules, 1 mole of molecules will be 18 grams. So 2 moles will be 36 grams. 2 moles of H2O will be 4 grams and 1 mole of oxygen will be 16 grams. So now if you divide this by 4, you will get 9 grams is giving you 1 gram of hydrogen and this is 16 is 32, sorry. Because this is the conservation, 36, 4 plus 32. It has to be equal, huh? And also 16, O is 16. So O2 is 32. So that means this will give you 9 gram will give you 1 gram and I'm dividing 32 by 4, 8 grams of oxygen. So that is why 1 gram of and 8 gram. So this is the ratio is 1:8. So you can also think in terms of molecule, atom also. If you got uh, this is 1 gram of molecule. So I mean it will be 1:8. Okay. So this is here we are talking of whenever we do this 6.02 is 1 mole and that is gram now, something which atom was in AMU, this gram. Here also this is now in gram. The other thing you should remember is that I just said H2O is breaking down into 2 moles of H2O is breaking down into 2 moles of H2 plus 4, 4, and O2. So this 36, 4, and 32. So law of conservation mass is followed. And once we break this down, we realize that 1 gram, this is 4 gram. Okay, there are 4 grams of hydrogen reacting with 32 grams. So 1 gram is reacting with 8 gram. So that's what he is saying. This ratio is fixed. 1 H is reacting with half of O, because there's another H. The O is being shared by 2H. So he's just saying. So that's why 1 is to it. So these things, and there are two laws. One was that this is found in a fixed proportion. Water you take from anywhere, America, India, everywhere, same, and the mass is conserved. The reactant's mass is equal to it. The and mass doesn't get destroyed.